am going to discuss aromaticity of annulenes. Aromaticity means a specific characteristics or set of characteristics shown by benzene and other organic compounds which resemble benzene. The characteristic properties commonly known as aromatic character or aromaticity shown by benzene and other benzenoid and non-benzenoid aromatic compounds. Aromatic compounds are unusually stable. This can be illustrated using benzene. The experimentally measured heat of hydrogenation of benzene is very less compared to the calculated heat of hydrogenation of benzene. Similarly, the heat of combustion of benzene measured and calculated is differed by 36 kilocalories per mole, which is the responsible for the stability of benzene. Aromatic compounds undergo substitution reactions even though it contains pi bonds. Aliphatic compounds containing pi bonds readily undergoes addition, whereas aromatic compounds undergoes electrophilic substitution. Similarly, aromatic compounds are resistant to oxidation, whereas aliphatic compound easily oxidized by Bayer's reagent, nitric acid, etc. And other properties. Basicity of aniline is less than aliphatic amines. Phenol is an aromatic compound, is a stronger acid than alcohols. Halobenzenes are much less reactive than aliphatic halo compounds. Effect of aromaticity on bond lengths. Aromatic compounds showing a bond length which is lesser than Cc single bond length of 1.54 Armstrong unit and Cc double bond length of 1.34 Armstrong unit. For example, even though benzene containing 3 number of single and 3 number of Cc double bond in the representation, actually no bond alternation is observed in benzene. All the Cc bond length is equal and observed to be 1.39 Armstrong unit, which is also observed in naphthalene, anthracene, etc. Slight or simple variation in bond length is due to partial bond fixation, not due to bond alternation. Resonance energy is the difference in energy of the most stable canonical form minus the true energy of the molecule. If you are comparing the resonance energy of 1,3-butadiene with benzene, there is a vast difference. 1,3-butadiene containing conjugated double bonds, its resonance energy is only 3 kilocalories per mole. Whereas benzene containing 3 number of alternate double bond shows a resonance energy of 36 kilocalories per mole. Similarly, naphthalene and anthracene having higher resonance energies, which is responsible for its more stability. Electronic absorption spectrum. Benzene shows 3 bands at 255, 205 and 183 nanometer in the UV region, whereas absorption spectrum of corresponding hydrocarbon is transparent in the UV region. What is the condition for a compound to be aromatic? The aromatic compound obeys Huckel's rule. What is Huckel's rule? A compound which is planar, cyclic, delocalized, containing 4n plus 2 pi electron are aromatic in nature. Aromatic compounds containing generally sp2 hybridized carbon. aromatic compounds also containing sp2 hybridized carbon. They are cyclic compounds, but they are planar, conjugated, cyclic, have delocalized 4n pi electron system. This system is unstable. Delocalization of pi electron in anti-aromatic compound causes instability to the compound. Induced ring current is another important property of aromatic compound. Pi electrons in aromatic molecules are not confined to individual atoms. The pi electron started to circulate at a faster rate in presence of the external magnetic field. The faster circulation of pi electron induced a magnetic field which opposes the external magnetic field above and within the ring and reinforces outside the ring. Therefore, protons present outside the ring resonate at lower applied magnetic field, whereas protons present above or within the ring resonate at higher applied magnetic field during the recording of NMR spectrum. So this area, induced magnetic field, is generated. The proton present outside reinforcing the external magnetic field, so it will come to resonance at lower applied magnetic field strength. So, olefinic proton usually absorb in the range of delta 4.9 to 5.7, whereas aromatic proton is deshielded and it absorbs at delta 7.2. That is, this type of delta value, that is higher delta value, means it is giving spectrum at downfield. If you are considering this compound 10-paracyclophane, the proton present exactly above the ring is a shielded proton and comes to resonance only at higher applied magnetic field strength compared to other protons of this methylene chain. Energy of pi molecular orbitals of aromatic compounds can be calculated using the formula E is equal to alpha plus 2 beta cos 2 pi r by n. Possible values of r can be given as 0, plus or minus 1, plus or minus 2, up to plus n by 2 if n is even, and r is equal to 0, plus or minus 1, plus or minus 2, plus n minus 1 by 2 if n is odd. For benzene, 6 carbon present, n value is 6. So what are the possible values of R? 0, plus or minus 1, plus or minus 2, plus 3, totally 6 values. So using the formula, if you calculated the energy level of different pi molecular orbital, the pi MO diagram will appear as follows. This is the pi molecular orbitals of benzene. Alpha is the atomic orbital energy level, whereas alpha plus 2 beta are the energy levels of pi bonding molecular orbital. This one is the pi anti-bonding molecular orbital. The magnitude of beta is negative. So, compared to alpha, alpha plus beta and alpha plus 2 beta are having lower values, whereas alpha minus beta and alpha minus 2 beta have higher values. These antibonding molecular orbitals having higher values. After hybridization, the pi electrons are present in lower energy bonding molecular orbital compared to atomic orbital. So benzene is stabilized due to aromaticity. Annulenes. Annulenes are monocyclic hydrocarbon that contain the maximum number of non-cumulated double bonds. Annulenes have the general formula CnHn for even and CnHn plus 1 for odd number of carbon in the ring, where n is the number of carbon atom present in the ring. So simplest annulene is cyclopropene. It contains only one number of pi bond. It is a 2 pi electron system. Here, one number of sp3 carbon is present in cyclopropene, so it is a non-aromatic compound. If you are seeing cyclopropenyl cation, so all the carbon are sp2 hybridized carbon, one pi bond and a positive charge. The pi bond and positive charge can be delocalized to any of the carbon. So it is a 2 pi electron system. N value is 0 means 4n plus 2 pi electron becomes equal to 2 pi electron. It is a planar one, cyclic and delocalized, having 2 pi electron, obeys Huckel's rule, and it is aromatic. If you are seeing the molecular orbital diagram, this arrow mark stands for energy level. This one is standing for alpha, that is energy of atomic orbital. The 2 pi electron present in the lower energy level molecular orbital, bonding molecular orbital, so it is the stable one. It is an aromatic, not so highly stable. That less stability is due to bond angle strain. Cyclopropenyl anion. So, 2 pi electron from the presence of 1 pi bond and a negatively charged carbon contribute 2 number of electron for the delocalization. Totally, it is a 4 pi electron system. Planar cyclic 4n pi electron system are anti-aromatic. So, this cyclopropenyl anion is anti-aromatic. You can see from the molecular orbital diagram, two unpaired electrons present in antibonding molecular orbital, so it is highly reactive and unstable. Cyclobutadiene. Now we are going to see the cyclic system containing 4 carbon. Cyclobutadienyl cation. So 2 positive charge. All carbon are sp2 hybridized carbon, 1 pi bond. The pi electron is present in lower energy bonding molecular orbital. This is atomic orbital energy level, but here no electron. In antibonding molecular orbital also no electron. So it is a planar cyclic 2 pi electron system. The 2 pi electron is delocalized due to the presence of 2 number of positive charge. All the carbon is in sp2 hybridized state. So it is an aromatic molecule. Cyclobutadiene. It is a perfect anti-aromatic system. It is called 4-annulene. So, see, 2 number of pi bonds are present. All the carbon is in sp2 hybridized state. So, it is a planar cyclic delocalized 4n pi electron system. It is anti-aromatic. It behaves as a diradical and highly unstable. It undergoes dimerization. Next example is cyclobutadienyl anion. It is a 6 pi electron system. How it is a 6 pi electron system? 1 pi bond, 2 number of negative charge. Each negative charge contribute 2 electrons to the delocalization. So totally a 6 pi electron system. It is plain or cyclic delocalized 6 pi electron system. So cyclobutadienyl anion obeys Huckel rule and aromatic in nature. Cyclopentadiene. Even though containing 2 number of pi bonds, it is non-aromatic due to the presence of this sp3 hybridized carbon. One carbon is sp3 hybridized in the ring system means it is non-aromatic. Next one, cyclopentadienyl cation. 2 number of pi bonds and another carbon is an sp2 hybridized carbon which is having a positive charge. So delocalization of pi electron, shifting of pi bonds and shifting of positive charge that leads to delocalization of pi electron. So it is anti-aromatic. A plain or cyclic delocalized 4n pi electron system, it is unstable. Cyclopentadienyl anion. See the structure. 2 number of pi bonds are present. So 4 pi electron. From this negatively charged carbon, a lone pair of electron is delocalized. That leads to totally 6 pi electron. This system is a planar cyclic delocalized 6 pi electron and obeys Huckel's rule. So it is aromatic. This corresponds to the molecular orbital diagram of cyclopentadienyl anion, 3 bonding molecular orbitals and 2 number of anti-bonding molecular orbitals. All the 6 pi electrons are present in bonding molecular orbital which are lower in energy compared to atomic orbital. So the molecule is highly stable. Next one is tropylium cation. Tropylium cation is a 7-membered ring. The ring containing 7 carbon. All the carbon is in sp2 hybridized state. This one is not aromatic. What is this one? Cycloheptatriene. One sp3 hybridized carbon. This carbon is an sp3 hybridized carbon. So it is non-aromatic. The cycloheptatriene can be converted to tropylium cation by removal of one proton from this sp3 hybridized carbon. Now all the carbon is in sp2 hybridized state. The ring system containing 6 pi electron and 1 positive charge. So delocalized 6 pi electron system. Cycloheptatrienium cation has 6 delocalized 6 pi electron, so it obeys Huckel's rule and aromatic in nature. From cycloheptatriene, in 2 methods, cycloheptatrienium cation can be prepared, that is otherwise named as tropylium cation. The aromaticity of tropylium cation is supported by many evidence. One of the evidence is the singlet observed at delta 9.28 in NMR spectrum. A downfield shift is observed due to delocalization of pi electrons and induced ring current causes deshielding of proton. The singlet observed at downfield. So all the protons are present in the same environment. UV absorption spectrum also shows maxima at 247 and 275 nanometer corresponding to aromatic compound. The tropylium cation react with nucleophiles. So this is cycloheptatriene. Removal of this proton leads to tropylium cation. The tropylium cation can give many number of resonance structures. The energy levels of pi MO of Cycloheptatrienium cation or tropylium cation are shown in this molecular orbital diagram. This diagram also shows that tropylium cation is highly stable. Cyclooctatetraene is an example of 8-annuline. This compound is not a planar one. Why it is not a planar one? Due to bond angle strain. This molecule exists in a tub-shaped one, so it is neither aromatic or anti-aromatic because the overlap of parallel p orbitals are prevented due to the presence of the molecule in the tub shape, so it is behaving as a non-aromatic compound. Regular octagon has bond angle of 135 degree. sp2 carbon bond angle is 120 degree. This deviation in bond angle makes that molecule cannot exist as an octagon structure. Instead of that, it exists in tub shape. So, there is the bond angle alternation is observed. 1.33 Armstrong unit and 1.46 Armstrong unit as polyenes. Anti-aromatic 8-membered ring compounds are existing. These two are examples. One example is benzocycloheptatrienyl anion. Another example is cyclooctadiene. Why this compound behave as anti-aromatic? This benzene ring make that system become a planar ring. It cannot be a tub-shaped ring. Here, on the whole, if you are seeing the center ring having 6 number of pi bonds, but 4 number of pi bond only present in one plane and delocalized. So it behaves as an anti-aromatic compound. Remaining 2 pi bonds is in a plane perpendicular to the remaining 4 number of pi bonds. Here 8 pi electron system, this ring, it is behaving as an anti-aromatic compound. System with a 10 pi electron system. All cis, monotrans and ditrans are behaving as an anti-aromatic compound, not behaving as an aromatic compound. Even though it is a planar cyclic 10 pi electron system is an expected one, 10 pi electron system means should be an aromatic compound, but in a planar one, the bond angle strain is very much larger, so this molecule is not a stable one. 144 degree for decagon, the bond angle. But sp2 carbon will exist only in bond angle of 120 degree. So the bond angle strain make that the all cis system become anti-aromatic, that means unstable. Similarly, monotrans also due to bond angle strain unstable. Ditrans, there is no bond angle strain, but the interfering hydrogen make that molecule unstable. So all these compounds, even though containing delocalized 10 pi electron system and cyclic system, they are not stable. One is due to bond angle strain. This is also due to bond angle strain. This is due to steric effect. Whereas 10-annuline can be prepared as a stable compound when 1 and 6th position hydrogen is removed. The steric strain is removed. How 1 and 6th position hydrogen of the 10-annuline can be removed? By removing that hydrogen by a bridge. Here methylene bridge, here oxygen bridge, here NH bridge. This bridging group remove the 1 and 6th position, the interfering hydrogen, and make that molecule become stable and aromatic. 1,6 methano 10-annuline, 1,6 oxido 10-annuline, 1,6 imino 10-annuline are stable aromatic compound. System with the 12 pi electrons is anti-aromatic, but due to existence of non-planar structure and bond angle strain, it is non-aromatic. 14 pi electron system according to Huckel's rule is aromatic. It is somewhat aromatic in nature because it is a bigger ring. The bond angle strain is somewhat eliminated. But here two types of hydrogen are present, 10 outer hydrogen and 4 inner hydrogens. The 4 inner hydrogen shows a delta at 7.6. The compound is destroyed by light and air. But this compound is an aromatic compound. 14 pi electron system, that is 14 aniline, can be made to stable when the interfering hydrogen at 16813 position is eliminated by methylene bridge or by oxygen bridge. This bis-methano-14 aniline, syn 1,6,8,13 bis-oxido-14 aniline are stable. This dihydro-14 aniline is also stable. One of the pi bond of triple bond is not involved in delocalization. The total number of pi electron involved in delocalization in dihydro-14 aniline is only 14 pi electrons. The trans compound is not a stable one because it is not a planar. System with 16 pi electron. According to Huckel's rule, 16 pi electron should be anti-aromatic. 16 pi electron system should be anti-aromatic. It is non-planar with alternating CC single and CC double bond and behave as a non-aromatic polyene. Next one is 18 aniline. It is a single ring compound. Many students used to say without observing it, it containing 6 number of rings. No, it is a single macrocyclic compound. It is a planar cyclic delocalized 18 pi electron system, obeys Huckel's rule and aromatic. The aromatic character is supported by the chemical shift value of delta 8.9 for 12 outer protons. According to induced ring current effect, inner protons are shielded proton and it comes to resonance at a higher applied field strength of delta minus 1.8. X-ray crystallography shows that this compound is planar, no interference of hydrogen. The CC bond distance are not equal, but they also do not alternate. There are 12 inner CC bond lengths and 6 outer CC bond lengths corresponding to outer bond length 1.4 Armstrong unit. Inner bond length is correspondingly 1.38 Armstrong unit. The resonance energy of the system is 37 kilocalories, similar to that of benzene. So it is a highly stable compound. Similarly, 22 anilines, 26 anilines, etc. are existing. Then what is homoaromaticity? In an aromatic system, an sp3 hybridized carbon is present, but that sp3 hybridized carbon lie almost vertically above the plane of the aromatic ring system. When cyclooctatetraene is dissolved in concentrated sulfuric acid, a proton adds to one of the double bond to form homotropylium ion. This homotropylium ion containing a 6 pi electron which is delocalized, the sp3 carbon is not present in the same plane, so the ring current is not affected. See, It is cyclooctatetraene in acidic medium is converted to homotropylium cation. This system is a 8-carbon system, one sp3 hybridized carbon present, but that sp3 hybridized carbon is forced to be above to the plane of the 7 carbon which form a cycle. 3 number of pi bonds. One pi bond is polarized and a proton is added, that sp3 carbon is present above the plane of the ring. The remaining carbon having the positive charge, 1 carbon. 3 pi bonds. So totally 6 pi electron and 1 positive charge is delocalized over the 7 carbon system. So it is called a homotropylium cation. This homotropylium cation is aromatic in nature, which is supported by chemical shift values and other things. Heterocyclic compounds which are aromatic in nature. These are all 5-membered heterocyclic compounds having 4 number of pi electrons, but a lone pair of electron from oxygen or from this imino-nitrogen or from this sulfur is used for delocalization. So this structure clearly shows the presence of 6 number of electrons which is delocalized. So they are aromatic in nature. Thiophene is more aromatic than pyrrole, which is more aromatic than furan because oxygen is more electronegative. It tries to hold the lone pair of electron towards itself, whereas sulfur is least electronegative and it contributes the lone pair effectively for delocalization of pi electron. Tropone is another aromatic compound. As such, if you are seeing this system is a non-aromatic one. But the carbon-oxygen bond is a polar bond. Polarization of the pi electron makes it oxygen negative and carbon positive. Because oxygen is more electronegative than carbon, oxygen withdraw the pi electron and the ring becomes a delocalized 6 pi electron system and the compound is aromatic. The dipole moment value of this tropone shows that they are present in ionic structure and aromatic in nature. Tropolone is hydroxytropone. This hydroxytropone, that is tropolone, also exists in polar structure due to polarization of pi bond on oxygen. If you are seeing this structure, it is a delocalized 6 pi electron system. So it is aromatic in nature. It is evidenced by absence of reactions corresponding to the presence of carbonyl group in tropone and tropolone. And carbonyl stretching frequency also is not observed. Its value is less. These compounds undergoes a variety of reaction corresponding to the presence of polar structure. Electrophilic substitution reaction is possible. Azulene is another system. These are all non-benzenoid aromatic compounds. It is a 10 pi electron system. Even though this structure appears as a neutral structure, this is the actual structure consists of cyclopentadienyl anion and cycloheptatrienium cation. Both are aromatic. So the whole system is aromatic. The molecule has a dipole moment value of 1.08 dB due to the presence of dipolar structure. The NMR peak at delta 7 to 8.2 is corresponding to aromatic one. CH stretching band also corresponding to aromatic one. Resonance energy of the molecule also 46 kilocalories per mole. So it is an aromatic compound. Signones are mesoionic compounds. Such a compounds cannot be expressed by a single structure. So they are ionic structure, delocalized ionic structure corresponding to aromatic in nature.